All right, in this video we're going to talk about parallel, intersecting, and skew lines. So given two equations of a line in space, L1 and L2, there are four possibilities as to what those two vector equations might represent. So the first three are really similar to what we had in the plane. Okay, but we'll see that in space there's a fourth possibility that you can't have in the plane. All right, so the first possibility is that the lines are the same line. Okay, and that's going to happen when the direction vectors for the two lines are parallel to each other, right? And it has all of the points in common. So you have what you think are two different equations of the line, but when you graph them out and check, right, you see that they are exactly the same line. That exact same thing can happen in the plane when you have two equations of lines in the plane. They could represent the same line. So that's still a possibility when we're talking about lines in space. Next up is that the lines intersect exactly at one point. All right, and that situation is going to happen when the direction vectors for the lines are not parallel to each other, and there's exactly one point in common. Again, that happens. It's similar to lines in the plane. You can have two lines and they intersect at a point. All right. The next possibility is that the equations for those two lines represent two lines that are parallel to each other. In other words, in that case, the direction vectors would be parallel to each other, but there's no points in common. The two lines don't intersect with each other. And again, just like in the plane, you can have parallel lines in space as well. But the fourth possibility here that you cannot have in the plane is that the lines are skew. And so skew lines are lines where they are not parallel to each other, but they also do not intersect. And so that one is new for lines in space. Remember, we're talking about a three-dimensional space, and lines are one-dimensional objects, so that gives them another dimension of wiggle room, right, to not intersect each other. There's more room to maneuver in space than there is in the plane. So you can have two lines that aren't parallel but don't intersect each other either. So you cannot have that right in the plane. All right, let's take a look at all of these possibilities. All right, and let me turn all of these off. Okay, so here we go. Down here we have these two lines. Okay, and you can see the equations look different here. All of the component functions are t. In this line, the red line, all of the component functions are 1 plus t. So on the surface of it, it looks like that is those two lines might be different, but then when you graph them out, you realize, hey, wait a second, they are the same line, right? If I turn this one off, you can see that's the red line. And if I turn the red line off, you can see that's where the blue line is as well, okay? So those are two equations, right, for lines in space that look different, but actually represent the same line. Every point that's on the blue line is also on the red line, and vice versa, okay? All right, so next up, let's look at the red and the green line. And the red and the green line are parallel to each other, okay? One way to see that, right, is if we look at the direction vector for the green line, it is 1, 1, 1, and that is exactly the same direction vector as the red line, 1, 1, 1. So these two lines, the direction vectors are parallel to each other. Okay, in fact, they're equal to each other, right? They're the same direction vector. But in this case, these lines also don't intersect, and so these are parallel lines in space. All right, next up, let's look at the red and the purple. All right, and in that case, here we've got two lines in space that intersect exactly at one point, and they intersect at the line 0, 0, 0. Okay. At the origin, and you can see if I plugged 0 in for t, right, in the purple line, I get all 3 zeros, right? So, and then for the red line, if I plugged in a -1 for t, right, I get all 3 zeros as well. So those two lines have this intersection point. All right, and finally, the sort of new case for space is skew lines. So here I have the red line and the orange line. When you look at it, right, just this view that we have right now, it looks like maybe they intersect. So you do have to be a little bit careful, but you can see, right, that's not the case. This red line just kind of ducks under the orange line, and they don't intersect at all. Okay. And they definitely are not parallel to each other, right? So, so there you go. Two lines that have that are not parallel and do not intersect each other. Okay. All right. So that's the 4 possibilities here. In the next few videos, what we are going to do is we are going to instead of graphing these pairs of lines out and looking at them, which is good to do to get the idea of the geometry that we're talking about. But what we really need is some way to tell whether which one of these, if we're given 2 lines, which one of these 4 cases that we're in. And we just are going to use a little algebra to do that.